We're going to talk about how to set up word problems. We're in algebra, so we've got to think about anytime we're setting up a word problem, there's an unknown, and we're going to use a variable for that. And that variable has to be defined. So when I say define a variable, I need to know what are you using that for. So if you say I'm looking for the unknown number, and I'm going to call it x, then x needs to be written, and then you're going to tell me that it's for the unknown number, or for the missing integer, or for the first integer, or whatever it may be, or for the feet missing. Then you're going to have an algebraic equation it's set up as algebra, not as some mixed form of just regular computation, just algebra. And then you have to have your work or process shown, and then your answer or answers with correct units. So if it's in feet, centimeters, if it's in area, then it has to be feet squared. If it's cubic, then so forth. So it has to have the correct units. You can tell me the answers to what? To elephants, to feet. If it's just the number 2 because it's an integer, then that's acceptable. But if it has units, it must be there. Now let's start with the first example. The perimeter of a rectangle is 24 inches. Find the dimensions if its length is 3 inches greater than its width. So anytime we're talking about something that we have an image for, we can draw a picture. So if we think about a rectangle, and you don't have to be an artist, but you can do like a quick rendering. Perimeter means to add all the sides together. We know that perimeter is going to equal 24 inches. That's a known. They gave us that. Now we have to find the dimensions. So we know that this is made up of length and width. And it says, find the dimensions that the length is 3 inches greater than the width. Well, we don't know the width. So let's call the width W. So there's my variable. So here I'm going to define it. W is going to stand for width. That's the only variable I'm using. I don't need an L because that has another setup. It says the length, which we have not marked yet, is 3 inches greater than its width. Well, if we call the width W, then the length is W plus 3. W plus 3. So now let's set up an algebraic equation. Now you could put all these together, or you could think about I have 2 W's plus 2 W plus 3's, and I know that's going to equal 24. Now I'm going to solve. So I have 2W plus 2W plus 6 equals 24. 2W and 2W give me 4W plus 6 equals 24. Move over my constants, and I have 4W equals, and then I have 24 minus 6 is 18, and then I want to figure out divide by 4, so my W is 4.5. Now, we keep it as improper, but that doesn't make sense to have an 18/4, or we could simplify it down, 9/2 of a length. So when we're talking about lengths of a board, it makes sense to put it into improper. So our width is 4.5. So now we have to find our length because it said it wants dimensions. Well, if we know our width, we can plug this back in here, or substitute a bin. This is 4.5 plus 3 is going to give us 7.5. So the length is 7.5, and we're talking inches. So this is 7.5 inches, and this is 4.5 inches. All right, on the next one, we're going to find the dimensions of each side if the perimeter is 365 units. We don't know if it's inches, feet, so we're just going to call it units. So we've got to find out what x is first. So if we know perimeter, if we add all the sides together, so we have first, we've already been given our variable as x. So x is a side length. We can say x is equal to line segment AB. Okay, so that's what we're using it for. So x is the side length of AB. So let's find that first. So we have x plus 3x plus 1, and I'll put parentheses to know it's a whole side, plus 3x, and that's going to equal 365. Now, let's combine like terms. We have a 3x and a 3x and an x. So we have 7x plus 1 equals 365. Now we're going to combine like terms on either side. So minus 1, Got little pieces on here. Let's get those off. And we have 7x on this side and 364 here. Now we divide by coefficient. So this x is equal to 52 units. So we know that this is 52 units. Now we can pull back in and find out what our other pieces are. So line segment BC from here to here is 3 times 52, which when we work that out is 156 units. And line segment AC is the same as 3x plus 1. We plug this in, 3 times 52 plus 1. Well, 3 times 52 was 156 before, plus 1. This is 157 units. And to check ourselves, we could add this all together, all of our sides, and we should get back to 365. All right, let's go to talking about consecutive numbers. This is kind of a cheat sheet you might want to think about. So when you think about consecutive numbers, those happen in a row. Consecutive means to happen one after the other. So if we're talking about just consecutive numbers, if we say I need to have 3 consecutive numbers, we don't know what the first one is, we're going to call it x. So it doesn't matter if it's odd, even, or they just say consecutive numbers, we're going to call it x. So we would pick x for a variable. Now you can pick a different variable. I like to use x. And we're going to call this the first term. You may call it the first unknown term, but it's the first term. If we're going in order, we would have x, and then we're going to the next one. So let's say we had 3 and we're going to 4. Well, that's just 1 away. So plus 1. So that's the second term. And then to get to the third term, it would be the beginning again, x, and we're going 2 away, so it's plus 2. This is your third. And then if we continue, x plus 3, x plus 4, x plus 5, and so forth. This would be your fourth, fifth, sixth term, and to how many ever it wanted us to do. Okay? Now, odd and even's a little different. So this is where people get confused. Now they have the same rule. So if it says I want 3 consecutive odd numbers or 3 consecutive even numbers, this is what we think about. X is still going to be our first term. We still don't know what the first one is. When we think about odd numbers or even numbers, let's just say, for example, we had number 1, 3, 5. These are odd consecutive numbers, just like 2, 4, 6, etc. are consecutive even numbers. Well, if I think about this first one being 1, how far away is the next odd number? Well, there's 2. It's 2 away. 1 to 2, 2 to 3. 2 away. Same thing here. It's 2 away. Same if I start with an even number. The next even consecutive number is 2 away and 2 away. So when we think about our next term, this is going to be x plus 2 would be our second term. X plus 4 would be our third term. X plus 6, X plus 8, X plus 10, and so forth. This would be our fourth, fifth, sixth, and so on. How many ever we needed to find. Okay, so this is very important to have if you want to copy this somewhere separate and put it like bold, highlight around it. So this is where you can go to if you forget how to set these up. So let's go to an example. All right, so twice the greater, so think about something that we're doing twice to, the greater of 2 consecutive odd integers. So we're talking about odd. Is 13 less than 3 times the lesser? Well, it sounds very confusing. So we're going to start with, first of all, what are we looking for? We need to find odd integers, and we have 2 of them, 2 consecutive odd integers. So let's set our variables up first. So we're going to call x the first odd number, and you think of integer, and we're going to call the second one x plus 2 is our second odd integer. All right, so now we have the variables and we have them defined. Now we're going to set up our algebraic equation. So it says twice the greater of the 2. Well, which one's greater? Well, x, and x plus 2, well, it's got 2 more than x, so x plus 2 is the greater. So x plus 2 is our greater, and it says twice that, so times 2. And it says is, so is means equals. So this side is 13 less than the other, okay? So we've got to think about what that means. So when we look at setting our other side up, this side is 3 times the lesser. Well, the lesser is x, so 3 times x, and then we got to count for that 13. So the 13 is 13 less than something. What's less than 3 times the lesser? It's less than this side, so minus 13. Now we have our algebraic equation, and we can now solve it. So distribute 2x plus 4 equals 3x minus 13, and now we're going to solve by moving things over. So minus 2x, we get 4 is equal to 1x minus 13 plus 13 plus 13, so we get 17 is equal to x. All right, so now we know that this first term is 17. And we know that if we plug 17 in or substitute it in, 17 plus 2 gives us 19. So our integers that we're looking for are 17 and 19. All right, let's try another one. Find 4 consecutive integers whose sum is 94. So is means equals, sum means to add. We know our total is going to be 94, and we're looking for 4 consecutive integers. Doesn't say even or odd, so they're just consecutive integers, like 1, 2, 3, 4. So we're going to call the first one x. This is our first unknown number. And then x plus 1, x plus 2, x plus 3. So this is our second unknown number, third unknown number, and fourth unknown number. Very important to have this set up. Don't start until you have this defined and set up. All right, so now we're going to go and think about these 4 are going to add up. The sum is going to be 94. So we know we're adding all these up. So we think about algebraically. X plus 1. I'm going to put parentheses around it just to know that we're talking about our little numbers. And the whole thing equals 94. So there's our algebraic equation. Now, let's count all of our x's. We got 1, 2, 3, 4, so 4x. And then 1 plus 2 is 3, plus 3 more is 6, equals 94. Now we have a very simple algebraic equation, and we solve. So 4x, 94 minus 6 is 88. Divide by my 4, so x equals 22. So I know that my very first term is 22. Add one more, I get 23. One more, I get 24. And one more, I get 25. So these are my 4 consecutive integers. All right, find 3 consecutive even integers whose sum is negative 42. So I want you to pause and try this one. All right, so I got x is negative 16. Now be very careful when we talk about negative numbers. We're taking negative 16 plus 2, we get a negative 14. Negative 16 plus 4, we get a negative 12. So these are our 3 consecutive even integers. Okay, so when I think about when things are negative, it looks different. Don't do negative 16, negative 18. They would not equal back up to negative 42. So be careful with that. All right, try this one. The lesser of 2 consecutive even integers is 10 more than 1/2 the greater. Find the integers. So pause and try. All right, so when we set it up, it says the lesser, or lesser is x, is, that means equals, 10 more. So that means x has got 10 in it. So we've got to give the other side 10 to make it even. Then 1/2 the greater. So 1/2 and the greater is x plus 2. So 1/2 x plus 2 plus 10. This plus 10 here makes this side equal to x because x already had 10 more. Now we could have also done x minus 10 is equal to 1/2 x plus 2. We still would have gotten the same answer. All right, so I used the clearing fraction method, and I picked my denominator of 2. I cleared the outside. So then I distribute, and I get x equals 22. Plug it back in, and I know my second term is 24. All right, so you're going to have some examples to do and some practice to do. Do your best and use your cheat sheet if you need for your consecutives.